And we're back with Matt the Muscle Mashad. Matt, can you read number 55 up to part A?
Figure 2 through 42 shows the velocity of a train as a function of time. At what time was its velocity greatest?
Okay, so this is a velocity versus time graph. How do you determine the maximum velocity?
Is it the x-axis, where it goes up like this? You could see the highest point in the green line.
Yeah, what time does that approximately occur at?
I would say about 48 to 49 seconds.
Yeah, good stuff. So this one's pretty straightforward. You literally just look for the highest points on the graph because it's a velocity versus time graph. Part B, during what periods, if any, was the velocity constant?
I would say from about 89 to 108.
Yeah, good stuff because it's a completely flat line, right?
Yeah, flat line there.
Nice. During what periods, if any, was the acceleration constant?
It looks like the acceleration was constant from about 0 to 47.
Yeah, any other times?
It's possible that the deceleration was constant from about 52 to 77, but the line is a little more curved there. I wonder, it doesn't look as flat. Do you think that would still be a constant deceleration?
That's a pretty good answer. So that's the key here. We're looking for any time that we have a completely flat slope. Acceleration is represented by curvature, right?
Yes.
Yeah, perfect. And so any time that it is a flat slope, we're going to be having a constant acceleration. From 0 to about 40 seconds, it would be positive acceleration. And yeah, from maybe like something around like, I think it's pretty flat from about 70 to 77. You know, there's no curvature there. So we can consider that to be a constant negative slope. There's one more period of time where things seem to be pretty flat. What is that?
Well, I would say 90 to 108, but that's at a constant. So it's not
Yes.
accelerating or deaccelerating.
Yeah, exactly. The acceleration would be 0, right?
Yeah.
Right, and that is considered a constant acceleration because it stays at 0 during that time. When was the magnitude of the acceleration greatest?
Would that have been from about 108 to 121?
That would be a pretty good consideration there. What we're looking for here is whenever the slope or the magnitude of the slope is greatest.
Oh, so the highest point.
Not the highest point, the greatest slope. So whenever it's like this, that's the least magnitude of acceleration. Whenever it's like this or like this, we have the greatest magnitude of acceleration. Magnitude means absolute value, so it doesn't matter if that slope is positive or negative as long as it's steep.
Okay, would that be about 89 or 90 then?
Definitely not 90, because at 90 it's flat.
Okay. So like 88?
I would actually say probably at about 70. 70 is where it's the steepest.
Okay.
Do you see what I mean by that? We're not looking for the greatest curve, we're looking for the greatest slope, the rise over the run. So, for example, we know that at approximately 50 seconds, the acceleration is close to 0. Because if we drew a tangent line across that slope, it would be pretty flat. Then it starts to dip down, and once it gets to about 70, maybe a little past 70, it's very steep in the downward direction. That means that we have a negative acceleration of high magnitude. So, for example, if at 50, it is 0, and then at 60, it's like -1, and at 70, it could be like -1.5, and then it starts to ease back to being flat. Those are all approximations, by the way. I'm not doing actual calculations here.
Okay.
So the other contender could be around maybe 110, where that slope is again pretty steep. Now it's in the positive direction, but we don't care about positive or negative because we're looking for the magnitude. So we're just looking for the steepest slope.
Okay, so the angle is
Yes.
the best place to start. The angle of the slope.
Exactly. And that's why it's not from 0 to 40. because from 0 to 40, it's just not as steep as it is around 70 seconds.
That makes sense.
Awesome.